welcome back to Mr. Hassan's Maths channel. In this video I'm going to start going through the October 2019 International A-Level Pure Mathematics P2 Pearson's Edexcel paper. This is called the October paper, although its date was on the 6th of November, and it was the second ever paper that was a proper paper that was sat for this new syllabus of P2 in the International A-Level. And there's not too much difference. There's a bit of slight difference between the new P2 and the old C2. The old C12 used to have trig graphs in all the trig graphs, and the trigonometry was all in the C2, but now the trig graphs are now in P1, whereas the trig equations are in P2. And also radian measure used to be in P2 and radian measure in the old C2, and now it's moved to the P1. And arithmetic series used to be in the old C1, and now that's moved to P2. And also there's a new topic, a brand new topic, which is about which is about proofs. So you have proofs, proof by deduction and disproof by counter example, which are new in P2. Okay, so that's basically a rundown of the changes. Otherwise, the paper, the timing is the same, 1.5 hours, and the number of marks is the same, 75 marks, and the fact that they convert that into a UMS mark, everything else is pretty much the same. So now, without much delay, I'm going to continue. I'm going to go through question number 1, and before I start, I just want to mention that I do sometimes go on a bit and explain things in a bit more detail than some of you might need, but I'm trying to focus for the students who really, maybe they didn't understand too well when they were studying the course for some reason, or they weren't able to access a teacher properly. So I want to try to explain things in a bit more detail. And also I like students to understand what's happening rather than just memorize how to answer questions. So, if you feel that I'm taking too long, I apologize, but I just want to explain that before I start. Okay, now, first of all, we're asked here, by the way, the instructions do tell us to write in black ink. Okay, in your exam, you must write in black ink, as they put in bold here. All right? And if you use a pencil for diagrams, which you should do really for diagrams, it must be dark HB or B, because they scan in these papers and they send them to the examiners like in electronic format. And so if it's a dark ink, it scans better. That's all. Okay, but I'm going to use blue just to give some contrast to the colors in my videos. That's all. Okay, I don't want to have it just completely black and white. So I'm going to use blue, although in your exam you have to use black ink and a dark pencil. Okay, now a curve has equation y equals 2x squared times x minus 5 in brackets. Part A of the question says find using calculus the x coordinates of the stationary points of C. Okay, so the first important thing here is the word stationary points. Stationary points. Now, a stationary point is basically a point at which the curve either stops increasing and starts decreasing, or stops decreasing and starts to increase, or it stops increasing and starts to decrease. So either it is a point like this, so it's going down, and then it stops to decrease, it starts to increase. This point at which it turns is called the stationary point. Or it's something that's increasing, then it reaches a maximum value, and then it starts to decrease again. This is also called a stationary point. These two types of stationary points are called turning points. This one is a minimum turning point, and this one is called a maximum turning point. You have other types of turning points, like they're called points of inflection, where something increases, then becomes 0, then it starts to increase again, or something is decreasing, and then the gradient becomes 0, and then it starts to decrease again. So it's increasing, it stops increasing for a moment, then it starts to increase, or it's decreasing, it stops decreasing for a moment, and then it starts to decrease. These points here, what's common between this point and this point, and that point, and that point, is that the gradient at these points is equal to 0. The gradient is equal to 0 at all of these types of points. Okay, so that's what a stationary point is. At the stationary point, the gradient is 0. So that's the important point here. At the stationary points in this function, or any function, at the stationary points, okay, I'm going to try and write. Let me just move my stuff around. At the stationary points, the gradient is 0. Okay, that's the important point. So the gradient, when we're talking about calculus, if we have a function y equals 2x squared minus 2x squared times x minus 5, the gradient is denoted by dy over dx. We normally say dy dx. So that's when dy dx, the gradient is equal to 0. Dy dx can be understood as the change in y over the change in x. This is the gradient function. This tells us about the gradient at any point in the curve that we want. So if I have the curve, now the equation of the curve is y equals 2x squared times x minus 5. Right now, it's not conducive to easily differentiate. Okay, you have to basically expand the brackets to have separate terms. So the type of differentiation that we deal with in P2 and P1, we want to have separate terms when we differentiate. So we're going to multiply the brackets out. So you have 2x cubed minus 10x squared. Now it's ready to be differentiated. Now we haven't differentiated, we just expanded the brackets, but now it's ready to be differentiated. We can say now dy dx is equal to, by the way, if any x's were in the denominator or there was any square roots in here, we would have to express everything as a numerator. Sometimes it had to have a negative power. For example, if this was 2 over x cubed, we would have to write 2x to the x to the power of minus 3. And if it was like, the square root of x, we'd have to write that as x to the power of a half. We have to express things in index form with everything on the numerator for all the x terms in the numerator for us to be able to differentiate. Once it's ready for differentiating, we multiply the power by the coefficient, so that's 6. And then from the x, we take 1 from the power. That gives you 6x squared. So multiply by the power, then take 1 from the power. And same thing here. You're going to have 2 times minus 10, which is minus 20. So we've multiplied by the power, and then we take 1 from the power. So there's a 1 here, which we don't have to write. X to the power of 1 is x. Okay, so that is now the gradient function. If I substitute any value of x I want in here, it will tell me what the gradient is at that particular point. When x is 2, for example, I put 2 in here, it will tell me what the gradient is when x equals 2. But what we want to do is kind of the reverse. We want to find the value of x when the gradient is 0. So we have to equate dy dx to 0, basically. Okay, so at the stationary point, as we mentioned, dy dx equals 0. So we know that if I put dy dx equals 0, what we're going to get is 6x squared minus 20x is equal to 0. Now this is an equation, a quadratic equation that we can solve by factorizing. Okay, now before we do that, we can see there's a common factor of 2. In fact, somebody might say, oh, there's a common factor of 2x. We're going to divide by 2. But I'm not going to divide by the x, because if I divide by the letter, the x, I will lose one of my solutions. Okay, if I divide by the x, I will lose the solution. I'm only going to divide by the number, the constant. That's common. Just to make my calculation easier. I don't even have to do that, but it just makes it a bit easier. So 3x squared minus 10x is equal to 0. You divide all of them by 2. Now, what we can do here, in any quadratic equation, if it's factorizable, which this is a simple type of factorizing where we take out the common factor of x. So you have x times 3x minus 10 equals 0. So now we've expressed this as a product of 2 factors which equal 0. So one of them or both of them are going to be 0. So either x equals 10, so that's one solution, or 3x minus 10 equals 0. Sorry, either x equals 0 or 3x minus 10 equals 0, in which case 3x equals 10 and therefore x equals 10 over 3. All right, we have answered the question. It says find the x coordinates of the stationary points, and we've done it. Okay, now be very careful in these type of questions, because sometimes they ask you to find the x coordinates only, and then you go on to find the y coordinates as well. You just see the word coordinates, you don't see the x. So then you find the y coordinates by putting x equals 0 and x equals 10 over 3 into the original equation, and then you write down the coordinates of x and y. I don't think you'll lose any marks for that, because you've actually answered the question, and they'll probably say ignore subsequent working, and what you write, what you're going to write after that, if you do it right, it won't be something that's wrong, but you're wasting time, and time is precious in the exam. So that's why it's important for you to read the question very carefully. They skim through the question and they don't see important pieces of information. So find using calculator coordinates of coordinates, okay, coordinates x and y coordinates, you go on to find the y coordinate as well. And sometimes the reverse happens. Sometimes the question doesn't say the y coordinate, it just says the coordinates. So in that case you have to find the x and the y coordinates, and some people, they just stop here and they don't find the y coordinate. So be very careful to read the question very carefully when you are answering such papers, so that you don't waste time or you don't miss out something that you're supposed to include. Okay, so that's the answer to part A, and that's done. Now for part B, it says hence find the values of x for which y is increasing. So the important word here is hence. Now some people, they might not understand what they see as hence here, and they might just see the question as saying find the values of x for which this is increasing, and they'll say, okay, I know how to do that. We've got y equals 2x squared times x, was it 2x squared? Yeah, times x minus 5. And they'll say, okay, it's increasing when the gradient function is greater than 0. Okay, and some people say greater than or equal to 0. Okay, there's a difference of opinion amongst the mathematicians. So both of these are actually correct. Okay, both of these are actually correct. I prefer this one myself, but both of them are considered correct, and the mark scheme actually uses this in the main answer, but then it says allow this in the notes. But anyway, so some people will think, okay, I've got to differentiate this, and then I've got to make the differential, which is, remember, it was 6x squared minus 20x. I've got to find the values of x for which this is greater than 0 or greater than equal to 0 if you want, and then you solve it, and you find you solve this quadratic inequality, and then you find the values of x for which this is true. But this is not what they're intending in the question, because of the word hence. If the question just was, this is the function, find the values of x for which this is increasing, yes, that's how you do it. You differentiate it, and it's increasing when the gradient is positive. That's when something increases, when the gradient is positive. So you say, okay, this is the gradient function. When it's greater than 0, it's positive. So if I find the values of x for which this is true, I've answered the question. But they don't intend that in the question. It says hence means using your answers that you just found. Okay, so it's something important. All right, it's something important. It's only worth 2 marks as well. Okay, so hence basically is using these 2 answers. Now, how can we use these answers to work out whether it's increasing? Well, there's 2 ways, and the simplest way, which is I think the way that they intended in this question, is for you to understand that the original curve is a cubic curve. Y equals 2x cubed minus 10x squared. When you expanded it, you got this. 2x cubed minus 10x squared. That is a cubic curve. And a cubic curve has a shape either where it rises, falls, and rises. Rise and rise. Or it falls, rises, and falls. Fall and fall. Now this is the case when the coefficient of x cubed is greater than 0. So for example, if you have y equals ax cubed plus bx squared plus whatever, when the coefficient of the x cubed is greater than 0, it rises and rises. When the coefficient of the x cubed is less than 0, it falls and falls. This one is going to be like this. It's going to rise and rise. Okay, it's not going to be like this one, because the gradient of x cubed is positive. So we know that the turning point, the stationary point, the point where the gradient is 0, are these 2 points here. One here and one over there. This point here and this point over here. And this is the point when x, of course, has to be 0, because the first, this is going to be, the 0 comes before 10 over 3. So this is where x equals 10 over 3. and this is where x equals 0. So we can see now that the shape of the curve will be like this, something like this, and this point is where x equals 0, and this point is where x equals 10 over 3. So we got to identify the parts of the curve where the y is increasing, where y is getting bigger. And you can see that y is getting bigger as x gets bigger, y gets bigger. X gets bigger, y gets bigger. X gets bigger, y gets bigger, and so on. But then at this point, as x gets bigger, y falls. So in this area, y is decreasing, and in this area, y is increasing. Y is increasing, and in this area, y is decreasing. It's going smaller, it's getting less and less, and then it becomes y. It stops increasing or decreasing. Then it starts to increase again. So we can see that's increasing in this area over here. It's increasing in this area over here. So basically this curve will continue like this. It will go up and up. So it'll continue going down here. So basically it's going to be increasing all of this time until it reaches this point. Then it starts to decrease. Decreases, and then at this point it stops decreasing and starts to increase again. Okay, so we can say that the values of x for which y is increasing are when x is less than 0 in this region here, when x is less than 0, and when x is greater than 10 over 3. Okay, now I hope you can see that when the gradient is positive, it's increasing. When the gradient is negative, it's decreasing. So whenever the gradient is positive, it's increasing. Whenever the gradient is negative, it's decreasing. Okay, so those will be the answers. Now, some in the mark scheme, it will mention x is less than or equal to 0, or x is greater than or equal to 10 over 3. And this is perfectly correct to write this. And this is what the mark scheme actually shows. And it's perfectly valid. There's nothing wrong with writing this. Okay? It doesn't, I mean, some people find it a bit confusing because at x equals 0, the gradient is 0 because that's the turning point. And at x equals 10 over 3, the gradient is also 0. So it's like it's a turning point. So it's not increasing or decreasing at that particular point. The gradient is 0. But what they mean is in this region here, when x is on this side, the gradient is when you're less than 0, the gradient increases, okay, until 0. So the gradient from 0 and before was less than what it was, and the gradient was increasing before you got to 0 until you got to 0. Then between 0 and 10 over 3, the gradient was decreasing. I personally prefer to write my answer in this way. X is less than 0 or x is greater than 10 over 3, because for me this makes more sense, and for the students of the level of we are in A-level maths, that's perfectly fine. We don't need to complicate things. But unfortunately, because the book uses this, the new P2 book uses this kind of method, and the mark schemes seem to have this as the main way of answering it, and then in the notes say allow this. That's why I have to go through this palaver of explaining what this actually kind of means. That it's between this value and that value, it's decreasing. So between 0 and 10 over 3, it has decreased between those two values. So that's why you include 0 and 10 over 3. If it was saying for decreasing, for example, or before x equals 0, it was increasing until that point. It's increasing all the way until that point, it was increasing. But that's one way of understanding it. The other way of understanding it is when the gradient becomes 0, okay, it's not increasing or decreasing. So you can say that it's increasing until it reaches just before 0. So that's where this answer comes from. And this is increasing just after 10 over 3. At 10 over 3, it's not increasing or decreasing because the gradient is 0. Both of those understandings are valid. But it seems like the people who wrote the book and the people who do the mark scheme, they prefer this particular method. However, both of them are perfectly valid, and they will give you the marks for both of them, as is mentioned in some of the notes of the examiners and is mentioned in the mark scheme. Both of these are perfectly acceptable answers. Okay, so that's an important point that I wanted to mention. I know I'm going on a bit, but I wanted to explain that because that's a big kind of confusion that students have, especially when they look at the answers of the P2 book. See, if that wasn't like that in the P2 book, then we wouldn't have to go through this explanation. All right, because I think it's just simpler to just keep it as I mentioned in this particular method. Anyway, there's another way. Supposing we couldn't draw this curve so easily, we didn't know what a cubic curve looked like, which we should anyway, or it was a type of curve that we were given, a type of equation that we were given that we weren't able to picture what it's going to look like. Then how would we work out whether the function is increasing or decreasing? Well, that would be, we would work that out by not using the method that I mentioned before, where you use the inequality, where you say, okay, the gradient is greater than or equal to 0 when it's increasing, and solve the inequality. No, I mean something else, because it says hence here, so we got to use these answers. When it says hence, it means use these answers. And you could use these answers in another method, and that is by finding what's called the second differential, okay, which is d squared y dx over dx squared. So we know dy dx, which is the gradient function, is equal to, as we said, 6x squared minus 20x. 6x squared minus 20x. That is the gradient function. Okay, don't write 3x squared minus 10x. That's after you've equated it to 0 and you've simplified it to solve. This is the gradient function. Okay, dy dx is equal to this. This will tell you the gradient at any point that you need on the curve. Now, we know that dy dx equals 0 when x is 0 and when x is equal to 10 over 3. So if we didn't know how to sketch the cubic curve, how would we work out which of these is a maximum and which of these is a minimum, or some other type of turning point like a station? How would we work it out? Well, one of the easiest ways of doing that is using the second differential, which is called d squared y over dx squared. Okay, because we're differentiating, we're basically differentiating dy dx with respect to x. Okay, that's why it's d squared y over dx squared. That's kind of like a little side point anyway. Now, as I was saying, let's differentiate with respect to x first. That's going to give you 12x multiplied by the power, take 1 from the power, and here the power is 1. It's not written, but it's 1. 1 times minus 20 is minus 20. And then you're going to make this power 0 because you've got to take 1 from the power. That becomes x to the power 0. Now x to the power 0 is equal to 1, and 20 times 1 is 20, so you end up with this as your second differential. This is called the second differential, and what we have done here is we have found the gradient of the gradient function. Found the gradient of the gradient function. Now what does that mean? Well, that means the gradient of something is its rate of change, how it's changing. So it's telling us how the gradient is changing. So we can see from here that the gradient of this curve is changing in such a way that it is positive. So for example, say the gradient here was 5, then it's become 4, then it's become 3, then 2, then 1, then 0, then minus 1, then minus 2, then minus 3. So the gradient is actually going from larger to smaller and smaller and smaller and even smaller. So the gradient is decreasing. So we can see this is a maximum point. All right, so when there's a maximum point, the second differential at a maximum point is going to be negative. That's a maximum because the gradient is decreasing. And when you have a minimum point, like here, this is a minimum point, you see the gradient here is starting off as a negative value. For example, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So as you go along here, the gradient function is increasing. So it's going to be greater than 0. It's increasing. So d squared y over dx squared is greater than 0. The gradient function, the second differential, the rate of change of the gradient is positive because it's increasing. Okay, so that's at a minimum point. So basically what we've understood here is that when we find the second differential for any particular point, and the second differential is negative, it means we've got a maximum. And when the second differential is positive, we get a minimum. So let's see if that works here. So this is d squared y over dx squared. This is the second differential. So let's see when x equals 0, which is one of the turning points. We get d squared y over dx squared is equal to 12 times 0 minus 20, which is negative 20. So we can see that the second differential when x equals 0 is less than 0. It's negative, therefore it's a maximum. And we can see that when x equals 0, we got a maximum. Okay, and we can see that when x equals 10 over 3, then we can say d squared y over dx squared is equal to, so you've got 12 times 10 over 3, 12 times 10 over 3 minus 20, which gives you 4 times 10, 40 minus 20, which is 20. So we can say that d squared y over dx squared is greater than 0. So therefore this is a minimum. Okay, so again, that's not the answer to the question. Now we know that when x equals 0, you got a maximum. When x equals 10 over 3, you got a minimum. So then you can do the same thing as we did before. If that's a maximum, then it's increasing before it gets to it. And if that's a minimum, then it's increasing after it gets to it. So that's the answer to this question. One more point I'd like to make, and I'll just make a bit of space underneath here just to explain to you. The question may ask you to give your answer in set notation. That's one of the things that's kind of new. So if you wanted to do that, you say x is such that x is less than 0, or if you want x is less than or equal to 0, if you want to use that method. Union with means or x is greater than 10 over 3. Okay, and of course you could put also inside here before the curly brackets, x is a member of the real numbers. You could write that if you want to be extra. So that is set notation. Okay, so x is less than 0 or union with x is greater than 10 over 3, or you could put the equal sign if you want. Both of those are acceptable. Okay, so there we have the answer to question number 1. I'm sorry if I went on a bit, but as I said, I like to explain some of these topics in a bit of detail for those students who might have missed out on some of the detail or have just memorized without understanding. And I like my students to understand what they're doing, and I find that makes it more meaningful. So thank you for watching. If you would like to see other questions from this same paper, please click on the playlist that appears over here. If you want to see other questions from this topic of the applications of differentiation, then you can click on this playlist that appears somewhere in this area below the first one. And if you would like to subscribe to my channel and get notifications when I make videos about various IGCSE or A-level papers, then please click on this icon over here. Thank you for watching, and I'll see you in another video somewhere.